Is there something you can see? Yes.
Yes.
Recording has started. Right. Perfect. Perfect. So let's do a quick recap what we covered last time. Can anyone give me the topics, just the highlights of what major topics we covered? If you can do that, if you're, I know there are people who cannot speak, they're because of the environment, but whoever can speak, you're free to do that. And I would encourage that you be interactive in the session so that you learn more and more. So if no one is able to do that, let me quickly do
Okay,
that
as I
for from my side.
remember
Yes.
last time, okay, as I remember last time we discussed about PAM, PIM, and then access policy. And
Okay.
I think in the first half we have seen how, the labs how to implement the policy. Are back.
Right. Those are some of the features which we have discussed. Okay. The major topic was Entra ID. Right. Entra ID is one of the major topic which we touch, and in that we discussed many other things. So Entra ID is very important. So I'll just quickly explain uh, a quick review. I'll do that on the whiteboard. And is anyone doing the labs by any chance?
Yes, sir.
I don't. Okay.
Completed
I,
that.
I just hear from you all the time. That's good. Okay. Whoever is serious about their journey in this cloud learning, I encourage them to always practice because that's really important. And now I'm going to share the screen on the whiteboard. Okay. So by now you definitely know what entity is. Okay. This is an IAM service from Microsoft Azure, Identity and Access Management Service. And the moment you subscribe for Azure services or any Microsoft cloud service, there is a tenant and ID tenant created for that subscription, right? So there is a tenant created and ID tenant. And what can you do with ID? What kind of objects you can create in ID? You can create the users, and when you talk about the
Just
users,
users.
yeah, you can create
Yes, sir.
basically users and groups, right? And in the users, there are different type of users you can create. You can create a local user. You can create the guest user. And what else? Is there a third type of user? Anyone? Mm, There is no third type. From the portal, from Entra ID portal, you can create only two type of users, local or the guest. But you can in the Entra ID, you will also see uh, something called synced users, synchronized users. And I'll just explain you in a bit what exactly that user means. This is something which you don't create, it is created automatically. Then you have two type of groups which you can create. You can create the security group, and you can also create a Microsoft 365 group. These are the two type of groups you create. Right, you have seen how to create the local group, local user. You have seen how to create the guest user. You have seen how to create the security group as well. We have not touched with this one because we can't do that. We don't have the service available, subscription available for this. And with Entra ID, you can do a B2B connectivity, business to business collaboration, and you can also do B2C, business to customer. So it's kind of a trust relationship. You can say this is nothing but a federation. In Entra ID, you can say this is. federation of identities. So you're trusting some other entry ID tenant or directory services, and you're trusting them to utilize their login IDs, the identities to access your resources. So in B2C, you basically are allowing any publicly available services like Gmail, Hotmail, or so on to use their identities to log into your system and access the services or applications from your entry ID. Right, this is what we did. We understood, and there is you also have on-prem scenario wherein you run the ADDS, Active Directory Domain Services, and this is like this is I explained you. It's similar to what we have in entry ID. It's like a identity and access management service, right? And there is a message from. Okay, just hang on a minute. Okay, Ahmed, you have any question? Because it will be difficult chatting during the session, so I won't be able to respond to your messages. You can ask that in the group. So
No.
It's not me.
Did I chat something?
Ahmed, not you. There's another Ahmed we have.
Okay.
We
Sorry.
have two Ahmeds here. So I'm just replying to him, saying that if you have any questions relating to the session, put it in the group, okay, in the WhatsApp group. If I'm not able to respond, anyone who in the group can suggest you and help you on with any issues you have with the session. But I really can't respond to one-to-one chats while the session is going on. I hope you understand that. And the link regarding the link, I have pasted in the group. You're part of the Azure Bootcamp group, WhatsApp group, right? Yeah, I guess you are on the session with us already. Do I see him? Yes, Ahmed Hashim Azmi. I can see you in the session. Okay, can anyone help him, please? In the background, if you can just, he's part of the group. You can see his name.
Okay, let me chat with him.
So when we have on-prem ADDS service, you can create the users and groups, right? On your on-prem environment, and you can also synchronize your users to your Azure instance to enter ID. So when do you need that? For example, okay, let's take this example. So I have my Active Directory domain services running on-prem, wherein I have all my users. Let's say I have 1,000+ users. I have my groups. These are users and groups. Now, I don't want. I'm going for the Microsoft 365 services. For example, I am taking an online subscription for the email services. So when I go for that, when I buy Microsoft 365 email service, particularly, for example, here. So I create a subscription. Now this subscription will have the entry ID created automatically, but there won't be any users created. Now I don't want to create those 1,000+ users here again on the entry ID. So what I would do is I want to synchronize users which are there in my on-prem setup to entry ID and activate the mailbox services for them. So how do I do that? There's a tool from Microsoft which is called. Can anyone name the tool? It's Entra ID Connect. Right? It used to be called as AD Connect before. Now it is called Entra ID Connect. So with the help of Entra ID Connect, it's just a tool. It's a utility It's a very small software which you can install on the main controller itself, or you can install it on any of the servers, which should have the internet access. So Entra ID Connect is something which you can use to synchronize these users to the Microsoft 365 AD instance. So the moment you have your subscription created, you have the Entra ID created, but you don't have any users, and you're not going to create any users on the Entra ID. You want to synchronize your users. So in this scenario, you will see something called synchronized users in the Entra ID. So when you see the list of users, you'll see local users, you'll see the guest users, and in the hybrid scenario, hybrid cloud deployment, you will see synchronized users as well. I hope that is clear. If you have any questions, you can go ahead, please. Right. So that was the discussion we had earlier. Sorry, what is this? Anyways. So let's start with our today's topic, and it's again one of the very important topic we have. We are going to discuss. And apart from Entra ID, we also discuss about Azure policy, right? We discuss about Azure policy. We discuss about role-based access controls, and you've seen there are different roles available on Entra ID. Uh, Different roles for Azure, managing Azure platform, infrastructure as a service platform, and managing the Entra ID itself. So you can create two set of different roles on Entra ID.
Tags also belongs. It's
Sorry,
tags. Tags.
we have seen the tags as well. Yes,
Yeah.
we have seen Azure policy, we have seen tags, we have seen resource logs. So all of this we have covered. If you just go through the, I'm sharing these slides as well. If anyone is not able to access it, I'll check it after the session. We can make sure that you can access the slides and use it. Okay, so today we are discussing about virtual networks. Now, on Azure, it's particularly the virtual networks you can only create in Azure infrastructure as a service model, right? I hope you understand the difference now between the cloud services. You have the infrastructure as a service, you have platform as a service, you have software as a service. So software as a service, which wherein you don't have any much control on the service itself. It is a service which is provided by Microsoft and it's managed and controlled end to end from Microsoft. You just consume that service. Platform as a service, you have some level of control to run and modify your code, which is mainly developed for the developers. Basically, the platform as a service is utilized by the developers. Then infrastructure as a service, which is the infrastructure, the complete IT infrastructure you can build on the cloud. Whether you can have your organization utilize only the cloud infrastructure for having your servers and everything services running, or you can do a hybrid cloud setup wherein you already have on-prem setup and you can connect the two. So those who know how the network infrastructure is built, they know that the very fundamental component for for IT infrastructure is the network. So you have to build the network first. You have to design. You have to do the networking, uh, build the networks, which requires many things actually. Physically, it requires cabling, laying the cables, installing the network devices, switches, routers, and so on. But when it comes to Azure network in the infrastructure as a service model in Azure, here you can do the similar things. Instead of doing the physical networking, building a physical network with your physical devices and the cables and so on, you're creating the virtual network on Azure platform. And that is one of the basic requirement in order to create any of your Azure resources. You have seen that already. When you create a virtual machine, it creates a resource group. It creates a virtual network by itself, whether you decide to create or not. It creates in the background a virtual network and a subnet for you. So this is what you see, what I'm sharing here. So if you see this, this is just for the explanation what I'm using. So the moment you create this virtual machine, you're just creating a virtual machine, right, on Azure. But what it is doing in the background, I've told you what exactly it does. It creates a resource group, and under that resource group, it creates a virtual network by itself, and it also creates a subnet under the virtual machine, virtual network. Clear? So that's how the virtual network is created by itself. I guess you guys are moving your cursors. I would suggest not to do that because those are visible on the screen. Karen, if you can just move away your cursor. Yeah, that's great. Right? So we will be learning about the virtual networks. There are many different features available while you're creating the virtual network. And let me tell you this thing again. When you compare this virtual network concept on Azure platform with other cloud service providers, for example, AWS, they do not call a network as a network. They call it as a virtual private cloud, VPC. They name it as VPC, which means virtual private cloud, which is nothing but a virtual network what we are creating on Azure. Just for your awareness and information. Okay, let's carry on. Let's solve this. These are the new features I'm just exploring for us to navigate easily. How do I stop this one? Okay, right. So going on now, before you build the networks, I've shared the link with you guys earlier about the IP addressing, and which is the fundamental building block for the network. So you must understand what is an IP address, or what is internet protocol first of all, and what is an IP address in the internet protocol. So just for your information, I've done this this slide here. IP address. There are two different versions of IPs available: IPv4, IP version 4, and IP version 6, IPv6. And in each type of IP address, you have two categories: private IP addresses and public IP addresses. You can see similarly in IPv6 as well, there is a private IP address and public IP address. An IPv4 address, Internet Protocol version 4, is a 32-bit numerical address used to identify devices on the network. So every device on the network must have an IP address. That is the only way it can communicate with other devices on the network, be it a Windows machine, desktop, laptop, or even your smartphone or any other smart device or the network or the device which can connect to the network and share the information. It is written in four numbers separated by dots, such as this. This is a very simple example of that IP address, which you can easily understand and remember. When you compare that with IPv6, which is the next version of IPv4, is a 128-bit address used to identify devices on network. The function of both is IPv4 address and the IPv6 address is same. It is for identifying a network device. It can be any network device. Nowadays, you have everything connecting to the network. Even your fridge, your TV, everything can connect to the network, right? So this it becomes a network device. So it gets an IP address. It will have an IP address assigned. So IPv6 is designed to replace IPv4 because IPv4 addresses are running out. So what does it mean? There's a specific set of number of IPs available, and those numbers are already running out, and it won't be enough because think about the whole globe, the internet throughout the throughout the world. every device connecting to the internet it requires an IP address, right? So imagine how many IPs are required for everyone to be connected online. IPv6 is like a new, bigger addressing system for the internet that provides trillions of possible addresses, ensuring every device can have a unique IP address. And this is an example of how the IPv6 looks like. Very complex. If you really want to learn, you should do it yourself. Because I really can't explain this. I have not done it before. Even IPv4 explanation, it goes deep down. It takes at least couple of hours to explain what exactly IPv4 is and how it works. So here for you to, on the high level, you should understand that the difference between IPv4 and IPv6, and that there are private IP addresses and public IP addresses. Now, how do we know which are the private IP addresses and which are the public IP addresses? Let's carry on. Here we have something called IANA, Internet Assigned Numbers Authority. This is the global authority which maintains the IP addressing, and so you can see that it's a global organization responsible for managing core technical resources on the internet, mainly IP address allocation, DNS root zone management, like .com, .org, .ae, all the root level domains, protocol assignment, and they decide on what protocol will have what protocol port number. So IANA is like a global authority that keeps track of internet's main address book and ensures everything stays organized. So that is the global authority, which and this from this authority we have got the uh, two different categories of IP addresses: private IP and the public IP. So you can see a quick comparison of the private IP and the public IP. The usage inside local network. So when you're building your own network, uh, it also applies to the network, virtual network, which we are going to create on Azure. It's going to be a private network, private for our organization, for our use. So and it will be local to the network. It won't be actually accessible over the internet. Okay. And public IP on the internet, it's available on the internet, and it will be there will be a unique. Every public IP is unique, so no two systems on available on the internet will have two same IP assigned twice. Reachability, private IPs will not be reachable from internet, and public IP is globally reachable. Uniqueness can repeat in different networks. Within the private network, you can reuse the private IP addresses. Must be globally unique, assigned by the routers or DHCP. I'll explain a little bit about that on the whiteboard. ISP or the cloud, who owns and manages the public IP addresses? It will be provided by your ISP. It's nothing but internet service provider. So whenever you take the internet connection, you get a public IP assigned by your internet service provider. It can be your home internet connection, or it can be a mobile data connection which you have on your smart phones and then smart devices these days. Or if you are talking about the cloud scenarios, the cloud provider will give you the public IP address. Example of the IPv4. So there's some mix up here in the slide. A private IP address, it looks like this: 192.168.1.10, and IPv6 private IP range, it looks like this. It starts with FD00. So these are the some differences which you can by which you can identify which is the private IP and which is the public IP. And private IP address you can see here starting with 52.23, and we have the specific set of ranges in the private IP and the public IPs. Okay, here we have IP address IP ranges with address counts. So there is a class A, B, and C. There are different class of IP addresses. What is the difference? See, this is the range. You see here, this is the private IP address range for class A, class B, and class C. And this is the CIDR representation of that /8. What does literally it means? you will have these many number of addresses which you can assign to the systems in your network. Now, can you imagine having these many systems in your one single network? It's it can be there might be a global organizations wherein they have so many devices and connecting to the network, virtual private network in their organization. But this is what is based on this, you will decide which private IP range to use for your network, class A, class B, or class C. So you can use any of this. And here we have a very uh, short example of IPv4 private IP range class C, wherein you can see the address starts with 192.168.10.0. This is start of the address, and it ends with 192.168.10.255, end of the address. And every IP address will have a subnet mask, which which actually makes it possible for you to understand which part of the IP is the network ID and which part of the IP address is the host ID, which will be unique across your network. For example, total IPs, it will have 256 usable hosts, including zero, starting from 0 to 255, it will be total 256 IP addresses. Usable host will be 254 because you can't assign 0, which is considered as a network address, to any machine, and you cannot assign 255, that's considered as a broadcast address. So for the computers in your network, you can assign IP addresses starting from 192.168.10.1 till 10.254. So you can see that this subnet mask is preserving the first three octet of this IP address. Only the last octet is changing from 0. It is going to 1 basically from 1 till 254. So if it is 0, you can't assign that to the machine. And if it is 255, you can't even again assign that to the machine. And you can use only these IP addresses in the class C range. This is just a very high level example of the IPv4. So we'll create virtual machine, virtual network basically. So I'll quickly go to the whiteboard. Okay, let's move this up. All right. So before we create the virtual network on Azure, let's take an example of the virtual network in at our home, right? Let's say you have your home internet connection. So what do you do with the if you need a home internet connection, you contact the ISP, right? You need to contact the ISP who can provide you the internet service. Now, once they provide you the connectivity, it can be a wired connection or it can be a wireless connection, right? So they'll give you the connectivity and they'll also give you something called router. Okay, so it can be a wireless wired connection or it can be a wireless connection. That's a very bad representation of wireless. Just understand that as a wireless for now. So this router, what you can do is you can use this most of the time. This is also Wi-Fi enabled these days, so you don't have to buy a separate Wi-Fi router. And this will be connecting to your network, to your switch if you have a switch at your home. If you are having too many network devices connecting, so with the help of this, you can do either a wired connection again internally, can connect to your laptop, can connect to your desktop as well, or you can have your smartphone or tablets, which will connect through the wireless, right? So this will be a wired and the wireless connection. So in this network, if you take this as an example, I'm sure everyone has this at their home. If not, you will at least have your direct internet connection from the ISP. You can see what IP address you're assigned to your device. So now this part of the connectivity from here to the ISP, This will work on public IP address. So ISP will assign a public IP address automatically to your connection. And internally from your router, you do most of the people who are not who are non-IT people who are no voice in IT, they just plug in the router which is provided by ISP. Usually ISP technicians will come and set up this, and they'll activate everything which is required for you to utilize that connection. So they'll enable the Wi-Fi, they'll enable wired connectivity for whatever devices you need. And on this router, there's something called DSCP. So you should know what DSP is because we are in Azure admin series now, and in the beginning, I've told you there are some prerequisites to run through this course. You need to have the understanding of how these different network components and IT components work in your IT infrastructure. So DSP is nothing but a dynamic host configuration protocol, which automatically assigns IP addresses to your machines in the network. So you will have an IPv4 address range configured on this. So let's say, for example, you have 192.168.0.1 till 192.168.0.254, right? This is the range of IP addresses. So the moment you connect to this router through wired or wireless connection, you will get an IP address assigned from this range. So every device will have an IP address. So for example, this is 0.1, 0.2, 0.3. Now this is your LAN. This is considered your local area network. So within the LAN, you can communicate with each other. You can share the files, you can share data and access the services from each other's machines. And when you need to access internet, it will go to the router. This router acts as a default gateway, right? It will also have an IP address assigned. Usually it will be 0.1, and that will be assigned to the default gateway, and other devices will have the other IP addresses. So this becomes a default gateway wherein it translates your private IP, because you have the private IP, and with private IP you can't access internet. You'll have a public IP assigned by the ISP, and your router is doing a lot of things for you in the background. It is translating your IP address. It is also, this router, by the way, is also configured as something called DNS server. What does DNS server do? It resolves the domain names to the IP addresses, right? As I told you, computers are good at remembering the numbers, not the names. But for us, remembering the numbers is a nightmare. We can't really remember. Can you remember the IP address of a particular website? For example, you want to access Microsoft.com. Now, you won't be going to the browser and typing an IP address to access Microsoft.com. You will just remember, it's so easy. You'll just put a name Microsoft.com, and it will resolve to the IP address which Microsoft is assigned to this particular domain. So so DNS is like your phone book, wherein you're mapping the number names and IP addresses. So DNS does the same thing. It has the uh, DNS mapping, the host name to IP address mapping. So this DNS server, what it does, it doesn't maintain all that phone book. It will actually redirect it to the DNS server on the internet. So on the ISP, they will have their own DNS servers, which will do the name resolution part for you. So locally, you will have DNS on your router, and on internet, your ISPs will have their own DNS servers. So these are if you just look at this very small, simple example of home internet connection, look at how many technologies you are interacting with. You have a router, you have DNS server, DHCP server, you have something called default gateway, you have NAT happening here, network address translation. So these are all your basic building blocks for a network, whether it is home network or it is an enterprise network in the organization. It functions similarly. The components might be different. It might be higher grade components. A router which we use at home, the same router cannot be used for the enterprise network because it has its limits, right? So this was a quick representation of the network, home network, and how DHCP will function, what DNS does, and private IP and the public IP. So you can quickly do search on your machine. What is what is your IP address, right? So if you want to know the public IP address, for example, if you go to the internet and see what and ask what's my IP, okay, it will show you. I'll show you this screen here. So see, this is what I've done on my browser. I just look for what is my IP address, and it shows me this is an IPv6 address, you can see, and this is the IPv4 address, which is a public address. So I have IPv4 and IPv6 both assigned. So each IP is unique, and you can see what who owns this IP address, because when it comes to the public IP addresses are assigned by IANA organization, IANA, and they assign the range of IP addresses to for different countries as well. So country wise, they assign separate set of IP addresses, so you can locate. This is how investigations happen when there are cyber crimes happens. So with the help of IP, they reach and pinpoint the locations from where this crime happened. So that's public IP plays a very crucial role. So if you are doing something illegal from your home network connection, so you might be able you might be traced back easily with the help of public IP. So ISPs will have the detail, and there is one more thing you should understand. There's something called static IP and the dynamic IP, right? Now, when you use static and dynamic, if you take this example, the home internet connection example again, the IP address which you get here assigned by ISP will be the dynamic IP address. That means it keeps changing. It doesn't remain the same. So the IP address which you see just now on my connection, what you see here is, it might not remain the same all the time. If I reboot my internet connection, if the connection resets or refreshes, it will the IP address will change automatically, and you won't even know, because it's a dynamic assigned IP address. Now, in the organizations, if you have some specific requirement for the static IP, you can use you can buy the static IP address from the ISPs again, but it will be costly. It will be really costly IP address, and there has to be a use case and the requirement for you to buy a static IP address. So in the cloud, you can see you easily see you can have a dynamic IP. You can even have the static IP. And in the home internet setup scenario, if you see this DHCP server, dynamic host configuration protocol, by the name itself, you can understand it manages this IP address assignment, right? It's automatically assigning the IP. So these machines are configured by default to obtain an IP address from a DHCP server. So the moment you turn on your Wi-Fi connection on the tab, it first of all looks for the wireless connection in your proximity. Then the once it is connected, it goes to the wireless router or the device which you have at home. It will try to get an IP address for the device itself, for the device from where you're trying to connect to the network. So that becomes a dynamic IP address. The moment you reconnect, disconnect your Wi-Fi, reconnect back, you'll get again, you might again get a different IP address, but from this range, right? So that's the difference between, and what is the static IP? Now, if you don't want, for example, you have a desktop, you don't want this desktop to have different IPs, because you're using this desktop, for example, as a file server. Let me. Let's say you're using this at your home as a file server, this particular desktop. So what does it mean? That means I have my NAS storage. I have a big storage, let's say 5 TB storage, and I want to use this storage to store all my data, whether I'm on tab or on my laptop or wherever. So in this scenario, I don't want this machine to have dynamic IP address assigned, because it will keep changing, right? It will keep changing. I don't want that to happen, and I want to assign it a specific IP address. So, for example, I need a static IP, so I'll assign it 192.168.1.10. So I can statically manually assign the IP address to this so that the IP becomes fixed on this machine, and I can easily access this file storage, which is attached to this machine. The moment you do this setup, you can call this desktop as a file server in your home and network, right? So these are the scenarios where you need the static IP address. So all this, whatever I'm explaining, all of this goes into the cloud as well. The same concepts, same requirements will also come in cloud, wherein you might require a DNS server, DHCP server. You might need a static IP or the dynamic IP as well. So we'll see all those things going through the slides and the labs. So we have labs, many labs for the virtual networks, right? Anyone has any questions, or we are good to continue?
Yeah,
You
quick.
mentioned static
Yes.
IP is supposed to be bought, so we can't set it up, like we can't set a static IP, or is it something we have to buy from somewhere?
No, no, no. Static IP is something which you see when again you have to understand your environment. If you're dealing with the private IP addresses, like a home network, which I have explained you, right? In this network, you can for your machine, you can have a dynamic IP or the static IP from the private IP range, right? When you
Okay.
talk about static IP, public static IP address, that is something which you have to buy from the ISP. So
Okay. So
that
for private,
distinction.
it's not a problem, only
Exactly.
public.
Private in the private IP range, you can assign dynamically. You can assign that IP. You can assign it statically, manually. You can assign to the machine. That's not an issue at all. But when it comes to the public IP addresses, when you're connecting to the internet, by default, most of the Wi-Fi connections, the internet home connections, they come with dynamic IP. Even on the enterprises, the normal internet connection comes with the dynamic IP address. Okay, so there are scenarios where you need the static IP address. For example, if you are hosting your own web server, right? If you are having on-prem scenario set up and you are hosting a
Mhm.
web server, you don't want your server to have different IPs every time the internet connection is reset, right? So what will happen with that case? In that case, basically, users cannot access the name resolution. Your website will not be accessible. I'll give you an example of that. So let's say, for example, um, using the same example, let's say we have a on-prem setup. Okay, in this network, I have my
Screen is not
servers.
visible
Oh,
actually.
sorry, maybe I'm sharing another one. Sorry, let me do that. Yes. So this is another way to check people are still, awake. So yes, you guys are awake. You're following me. That's the confirmation. So I have my infrastructure set up here. I have my file server. Let's say I have a web server as well, and I want to host my own website. By the way, it becomes a very costly business when you do that yourself. So what people do usually, they go for hosting service providers. So if I want to host my own web server, and that web server name is abc.com, and I want this to be available and accessible over the internet to anyone, right? That's the purpose of website, right? This is the user on the internet. So this is my internet cloud, for example, and I have my this user has internet connection, wireless, wired, I don't care. It has internet access, and this server has to be on internet for sure, connected to the internet. Now this will be done. This can be done in different ways. First of all, you need the connection from ISP, which will again require some router on your network, and it will connect to your LAN, local network. So this won't be just a router. There will be too many things behind this firewall. There'll be NATing happening, network address translation will be happening, and so on. And on the internet, you will have your name registered. So the host name will be registered and reserved for you. So you purchased this domain. You can buy the domain names from internet, abc.com, and you also bought a public IP address. So in this scenario, if you want your website, if you want to host your own website on-prem, you have to do these things. You have to buy a host domain name first of all, the name for your website. Secondly, you need to also buy a public IP address. Okay, and this has to be a static IP, static public IP address. So that means it will be a fixed IP address assigned to you, and that you can map on the DNS server. It will be mapped. So let's say there's a DNS server on the internet which manages your domain name. So that name, let's say an example of 5.2.3.4. This is my IP address, for example, public IP, which I have or which I own. So on the DNS, your abc.com will be having this IP assigned, mapped 5.2.3.4. This is all which goes in the background. So when the user accesses the site, he doesn't bother about the IP address what you have. He will just type in the address of the domain of the URL address, and then that gets resolved to this particular IP. And this IP, as I told you, this will be a unique IP. No two internet domains will have the same IP address assigned. So in the internet cloud knows where this IP is, first of all, which region it belongs to. For example, this user is in the USA. Does he need to bother about where your website is hosted? Let's say this setup is in India. This is where my organization is. This is where I have my web server hosted. User is least bothered about where the site is, where the website or web server is located. So this IP address will be routed over the internet. It knows that this IP range, it will definitely belong to Indian continent, right? Because INA is assigned a range of IPs to every region. So based on that, it will identify that, okay, this is the Indian IP address, and this is the local ISP. For example, Reliance is one of them. So it will go to the ISP. It will also know which ISP it owns this IP address is owned by, and then it will from there it will know that this IP is actually bought by this customer and it is assigned on this particular router. So the actual IP will be here. This static IP will be assigned here, or it will be configured to NAT. So the moment the traffic comes for this IP address here, you will have this device which will do the NATing, and it will map your public IP to the internal private IP address of the web server. So this is where the static public IP is required. Now, in this scenario, you can't have this IP changing, right? Every time the IP changes, you have to go and change the DNS entry, right? And it takes time to refresh the DNS globally, and the user then only user will be able to the experience of the user will be consistent. I hope that explains the requirement of public IP static IP address.
Yes, yeah, completely.
All right. Okay. So let's go
Maksud
back
bhai,
to
I have one
yes,
question. Can
yes,
I?
yes.
So
Of course.
I know about this DNS, IP and all. So my question is, based on the use cases, this will be used, like whether we need to have the statics or dynamic.
Hmm,
So based on the user access, we will go with the dynamic IPs and all. So for the server perspectives, uh, we are using the statics IP because we should not change anything. Internal communication also required. So
exactly.
it's
The
totally
exam,
based. Yes.
the example, the home network setup example which I've given you, wherein you're configuring or setting up your desktop machine as a file server, right? When you make
Mm,
it as a file server, you don't want that machine to have different IP every time you start that machine. So
mm,
we are setting a static IP address. So similarly, when you have servers in your enterprise network, it is a best practice to assign static IP addresses. Now, this is where the question came in, whether can we assign the static IP address public? There is a distinction here. Static IP address can be a private IP address again, from the private range if you are in the local network. It can be a public IP address if you are buying it from the ISP.
Yes.
So is that clear? You have anything else to ask?
No, good to go.
All right. So create a virtual network. We will be seeing how we can create the virtual network. Uh, you can create it anytime. Now, unlike other resources in Azure, when you create a virtual network, you don't have to pay for it, right? When you create a resource group, you're not built for the resource group itself. Resource group is nothing but a container. And when you create a virtual network, it's also not built until you use that virtual machine for transferring data between your on-prem setup and Azure Virtual Network. So only the data transfer is charged, not the actual virtual network itself. So at virtual networks, when you create a virtual machine, this we have seen, when you create the virtual machine, it automatically creates a virtual network in the background, defines the address space and at least one subnet. So this is what I have explained at the start. So when you create your virtual machine, it automatically creates a virtual network. It creates the address space and the subnet, one subnet at least. And there's a point here, check for overlapping address spaces. So this is very important. What do you mean by overlapping IP addresses? If you're using a set of IP addresses or the range of IP for your on-prem setup, it's not definitely a good idea to use the same IP address range for creating a virtual network on Azure. Because in the future, when you collaborate, when you have a connectivity between your on-prem and Azure network, it will not work because if you will be having the same IP addresses on both the sides. So that's what it means. Overlapping addresses, you have to make sure that you don't use the same IP address range which you are using on-prem scenario on your network. Right? In each virtual network, you can create multiple subnets, right? Multiple subnets is like blocks, block of IP addresses. If you see here, subnet 0, subnet 1, subnet 2. So each has different set of IP addresses, and it shows you number of available IPs in each subnet. Now, how do you decide to create number of subnets based on what? We'll see there are multiple use cases wherein you need different subnets to be created. A virtual network can be segmented into one or more subnets. Excuse me. So by default, when you create a virtual machine, it creates one single virtual network. It creates definitely one subnet. Subnets provide logical division. And this is the purpose of subnets within a network. So within one big network, you can create the subnets to segregate or divide the workloads. For example, you have development servers and you have your production servers. So you can segregate in order to have better control on communication. We'll see when you see this in action, when you see in whiteboard, it will give you a much more clear idea. Subnets can help improve security. This is another reason why we subnet the virtual network. In one virtual network, we create different subnets, increase performance, and make it easier to manage the network. So if you are a network admin, this is definitely a best practice and a good idea to always divide your network in multiple subnets in order to manage it easily. Each subnet must have a unique address range, cannot overlap. So if you see here, for example, subnet 0, it has a different IP address range, 10.0.0.0/24. Subnet 1 is slightly different. If you see 10.0.1.0, so it's not exactly the same. So you can't have overlapping address ranges within a virtual network for two different subnets. Subnets, Azure reserves 5 IP addresses within each subnet. So we have seen an example of IP. Sorry, what is that? Class C range IP, private IP range, wherein you see that the 0.0 is always reserved for network address. You can't assign that to any machine in the network. And in Azure, when you're creating a subnet, This is what you need to remember this for the exam. These are all examination questions. 0 is reserved for the network address, 1 reserved by Azure for the default gateway. So you have seen what is the default gateway in the home internet connection example, what I have explained you. The router will have an IP address assigned to it on the interface, which functions as a default gateway. And you know why it is called default gateway? Because when you are accessing internet, your network connection is going through the router to the internet. So it becomes a gateway to the internet. So it is called default gateway here. So when a virtual machine needs to talk to another virtual machine in another subnet, it will go through this Azure default gateway address. I'll explain you on the whiteboard again. Dot 2 and 3 reserved by Azure to map the Azure DNS IPs to the VNet space. We'll see what exactly this means as well. So a subnet is actually functioning as a DHCP server in Azure Virtual Network, and it is reserving this IP addresses first of all. Dot 1, dot 2, 3, and the dot 255 is a network broadcast address which cannot be assigned again to any of the virtual machines. So rest of the IPs from dot 4 till dot 254 will be available for you to assign to the virtual machines which you create. And those IPs are again automatically assigned. The moment you create the virtual machine, it will automatically get an IP address from the private IP subnet which is created under your virtual network. As a best practice, you may decide to separate dynamically and statically assign IP resources into different subnets. So this is one more uh, suggestion here, that you can create two different subnets. One which you can use it for your critical servers for assigning the static IP, making sure that you have those servers have static IP addresses. So you can manage that particular subnet separately, and you can have one more subnet wherein you have development servers, and those servers can have dynamic IP addresses assigned, which will not be an issue for you at all. And IP addresses are never managed from within a virtual machine. What does it mean? This is a very important point. So if you have to change an IP address on a virtual machine on the OS level, for example, I have a server, Windows Server installed. Now, there are requirements when you need to assign the IP manually, static IP address for your server. So you can't do that on the OS level. On the operating system, you can't go and change the settings. There is a different way of doing that in Azure environment. We'll see that as well. Okay, plan IP addressing, private IP addresses, public IP addresses. Let me go back to the whiteboard. I'll explain you how this actually, whatever we have discussed. Okay, so this is where we are. Let me use the other one, black one. VNet, nothing but a virtual network. And I told you the same concept applies on when it comes to AWS, they call it VPC, virtual private cloud. That's what they call it. In Azure, it is called VNet. Very simple to understand. So this is your virtual network. When you're creating a virtual network, you have to decide what IP address range you want to use. For example, by default, it suggests you an IP address range slash 16, for example. Okay, what does it mean? So if you go quickly do a Google, IP subnetting, subnet calculator. Okay, so I'm saying I'm going to use 10.0.0.0 slash 16. Calculate. So it gives you the calculation on this subnet, what we're trying to use for the virtual network. So this is the network address and usable host IP ranges. These are the host IP ranges we have. So how many number of hosts you can have in this network? 65,536 hosts. Why are we creating so big network? Why are we picking so big network range? It's a good practice. It's a best practice. This is a private IP range. It doesn't harm whatever subnet you choose. So it will be easier for you to expand your network and have whatever number of requirement you have in the network to create. You can divide this host. You can divide this network, this big network, in multiple subnets. So it shows you what is the subnet you will have assigned when you say /16. And what else you should see here? Yeah, so basically you can quickly do the IP calculation and see how many IPs will be assigned for this address. So this address range will have 65,500 IP addresses in it. This you can further divide into subnets. So I'll create, let's say, for example, 0/24. So mostly we go with /24. That's again easier to manage and maintain. So I can create subnets like this. Okay, so how does it look like? Go back to the calculator again. So I'm going to do /24 now. So in /24, I will get number of usable hosts, 254. These are the usable IP addresses I will have. And when I go with /24, I have to make sure that I assign this as a subnet mask for a machine. So what does it mean? Subnet mask really plays a very important role in here to distinguish between the IP address and the network address. So for example, if you have this machine, this is a virtual machine, and you have an IP address assigned 10.0.1.0, so for 1.2, for example, and I say that this is from /24 subnet. That means it will have a subnet mask assigned like this. So if you have seen how to assign an IP address on your machine anytime, you will know. With an IP address, you definitely have to assign an subnet mask. So this tells the machine that this is the network address, your subnet address, network ID basically, and this is the host ID bit. And this has to be unique in the network. So within the network, let's say this is your network 192.168.1.0/24. This is my network. So in this network, the subnet mask will be common across all the machines. So if I have one more machine here, so I'll assign the IP address 192.168.1.3, for example, and it will be part of same network. So 255.255.255.0. So this subnet mask has to be used across all your machines. This one becomes your network ID, and this part becomes your host ID. So it is actually distinguishing this part, the actual IP address. So subnet mask is used to distinguish the difference between these addresses. So it tells your machine that, okay, this is the network address. It can be common across all the virtual machines. It's not an issue, but this is the unique ID. So if I try to assign this machine a same address 1.2, it will be a conflict. So your machine will definitely detect that there's a IP conflict, and you can't use that. No two machines can have the same IP address. So that's a simple explanation about the IP, the subnet mask, right? So now we are creating this virtual network big. We always should pick a big range, which you can divide in multiple subnets. So now how you decide to divide this? As I told you, we can decide it based on the environment requirement. For example, if you have, let's say, if I'm creating subnet, this will have my production servers, prod servers. I can divide this virtual network in a subnet, and this will be for development. And I can also decide, create a subnet for network connectivity. So for example, this subnet is for network. That means I can deploy a firewall in this network, which will protect the traffic flow between these subnets. So we'll see all those things, but how you decide and how many subnets you need for each of your subnet and your network, it really comes down to your design. So this is one dot, for example, this is we are using the different range here. So your subnets has to be within the range of this bigger uh, bigger range which we are using for VNet. So in this VNet, this is my range. I cannot have the IP range assigned to a subnet with 192.168.0.0, for example, /24. I can't do that. It has to be from the same range. Okay. So here I'm assigning this my production subnet as /24. This one will be 10.0.1.0/24 and so on. So I divide my network, virtual network, within subnets based on the requirement. So, so that comes down to the planning part, the designing part of the virtual network. So it's really crucial and important because once you have the virtual network created, everything, whatever you deploy on Azure, whatever resources you deploy, virtual machines, storage, they're all going to be part of the same virtual network, and they'll be associated with one of the subnets. So any changes on this virtual network, it will have an impact on all the resources which you deploy. So it's really a very important decision and design decision. Basically, when you're designing your virtual network, there's no harm going for the big IP range like Azure itself suggests, going with 10.0.0/16. If you know that okay, I can't go with this IP range what Microsoft is suggesting, because I have this IP range already used on my on-prem setup. Let's say you have on-prem setup, and here my network engineers are already using the same range /16. In this scenario, I can't do that. I can't actually use the same IP range in here. What will happen? For now, it is different. Both are segregated. This is on the cloud. This is on-prem. There's no problem with this. You can still have this. Until when? Until when you have a connectivity between your on-prem and the VPC, the virtual network. Then it becomes a problem. So you can't use the same IP ranges because it will be a conflict and there will be routing issues. You can't really have same IP ranges assigned on-prem as well as on your cloud. So if you're building your Azure virtual network, if it is a fresh deployment, you don't have any on-prem setup. Your company says that okay, we straight away want to use the Azure Virtual Network. We don't have any on-prem scenarios in this case. So you can choose whatever IP range Microsoft suggests. You can just go ahead and use that, right? If you already have an on-prem setup, and your plan is to extend your data center to Azure, then definitely you have to consider this. And in this scenario, for example, you can't use if this is already used in on-prem. What I can do is I can go ahead and change this. I don't accept what you're saying, Azure. What I'll do is I'll create my own IP range. So you can create, for example, 10.2.0.0/16. It's a complete different range of IP address. So there's no conflict in this /16, or you can even choose something different, which is completely different than what you're using. If you have any doubt that okay, 10.IP range can be used on my on-prem setup, it's a huge network. Maybe it is used somewhere else. So it's always better to check your on-prem IP addressing scheme first, and then go ahead and design and decide the IP addresses for your public IP, the virtual network IP addresses. So I'll go ahead with this IP range, for example, /16. This is not an issue. So in this case, I have again a bigger network. virtual network, and I can divide this in multiple subnets as you require. Here, so IP addressing, deciding on IP address ranges is crucial, and it's very important because the moment you create a virtual machine, virtual network, it remains as is. Subnets, yes, definitely you can create and delete the subnets, but the virtual network itself, the first virtual network which you create, you can't really make many changes to it once you have the resources deployed. If you don't have any resource deployed, you can delete the virtual network, recreate it with whatever IP range you want. It doesn't really matter. Okay, I'm going back to my the slides again. So here it is again the discussion about plan IP addressing. So you can see that VNets, on-premises networks, VPN gateways, express routes, they all use the private IP addresses because this is all the communication stays private and local in within your environment. Either it can be within your Azure infrastructure or between your on-prem and Azure infrastructure. When you talk about going to the internet, public-facing services, you definitely need something called public IP addresses. We'll see that in the practical in the lab, and you'll have definitely better understanding. So private IP addresses used within an Azure Virtual Network and your on-premises network when you use a VPN gateway or Express Route Circuit to extend your network to Azure. So we'll see, we will be seeing all these things in this series today and tomorrow. Public IP address used for communication with the internet, including Azure public-facing services. Right? You can also so here there's an example here. You can create a public IP address, static IP address if you want on Azure portal, available in IPv4 or V6 or both. So it's like you buying the public IP address from your ISV. So on Azure, you can buy it as a standard SKU. So as I told you, this is the term which is used for e-commerce shopping. So standard, what is it called? Keeping unit. So you have different variations available from Azure when you're buying the public IP address. You can see there are different features. So dynamic versus static. So the price will definitely vary between dynamic and static. Dynamic will be cheaper than static IP address because when the moment you say static IP, that IP is reserved for you throughout the globe. No one in the whole internet globe will have the same static public IP address assigned to you. Even that remains the same even for dynamic IP address. When you talk about public IP, it is unique. Whether it is dynamic or static, no two connections on the internet will have the same public IP address. But the difference is dynamic keeps changing. So your ISP will have a range of IP addresses from which it will keep assigning you the IP address on every connection you have, or whenever the IP address refresh happens. Or if you are hosting a web server, for example, I have given an example of the web server, hosting the web server on-prem, right? The same thing you can do on Azure. On Azure, you're building your whole infrastructure, you're building your virtual network, you're building your virtual machines, and on that virtual machine, you can make it as a web server. We have seen installing and deploying Nginx Linux based web server in the previous labs. So when you have that web server running on your environment on Azure platform, Azure infrastructure, now to make that website available and accessible to everyone over the internet, you would definitely prefer to go with the static IP address for it, static public IP address. So you can buy that IP, from Azure, right? So when you're buying the public IP address, you have different options here. You have an option to buy IPv4 address or IPv6 address. There is a standard SKU available zone. There's a zone availability as well. We'll discuss this later, what exactly it means. Regional, global, and you can see here IP address assignment, static or dynamic. So you have an option that the dynamic is grayed out because it's automatically assigned. It's not something which you can buy. You can buy a static IP address from Azure, and you can assign it to the web server which you are running. So we'll see there are different options in this. Associate public IP addresses. Now, where you need the public IP address to be assigned. You can assign to a virtual machine network interface card. It can have a dynamic address. or a static address. That means a public IP which is dynamically assigned by your service provider, or the one which you have purchased, you can dynamically, statically, manually assign it. Load balancer, front-end configuration, IP address you can assign to the load balancer. We have not seen what load balancer is. It's coming up next. I'll explain you on whiteboard what exactly the load balancer means, where we use the load balancer. Here it is just showing you where all you can assign the public IP address. So that means these are the components. Virtual machine, you can assign it to virtual machine. You can assign it to the load balancer. You can assign it to VPN gateway, application gateway. These are the components where you can assign public IP address. A public IP address resource can be associated with virtual machine network interface, internet facing load balancer, VPN gateways, and application gateways. Exactly what I've told you. Static IP addresses only available on certain SKUs. So we'll see all this when we do the labs. Okay, that was about previously it was about public IP addresses. Now we are talking about allocate or assign private IP addresses. Now you can assign a private IP to your virtual machine. You can assign the private IP to internal load balancer. We'll see the difference between the public load balancer and the internal load balancer. Application gateway. Yes, so it is just telling you that you can assign an IP address, a private IP address. It can be dynamically assigned, or when I say dynamically assigned, it will be assigned automatically by the Azure Virtual Network. Or you can manually assign it. Static IP address means you manually assign an IP address to a virtual machine or to a load balancer or application gateway. Dynamic IP address is by default assigned by the virtual network. Azure assigns the next available unassigned or unreserved IP address in the subnet address range. This is what so Azure Virtual Network itself is acting as a DHCP server in this scenario. The one which I've explained you on-prem on the home internet setup. You have a router which is provided by the ISP, and that router is enabled with DHCP protocol, which means it acts as a DHCP server. It assigns the IP address to every machine which tries to request for an IP address on your home network. So similarly, when you have a virtual network VNet created on Azure, within that VNet, you are creating subnets. So every subnet will have DHCP function automatically enabled by default. That's the default behavior. So the moment you create a virtual machine and assign it to a specific subnet, it will automatically get an IP address assigned. So that is called dynamic IP address. Static, you select and assign any unassigned or unreserved IP addresses in the subnet. So you can I'll explain you what is unassigned and unreserved IP in a bit. So let's go to the whiteboard, make it much more clear before we run through all the slides. Okay, let's draw a virtual network first, a block. This is, let's say this is my VNet virtual network with an IP range 10.0.0.0/16, right? And in this virtual network, I'm creating a subnet. So by default, when you're creating a first virtual network, you definitely have to create at least one subnet, which is called a default subnet. By default, it's the name itself is called default subnet. Okay, and it will ask you to assign a range from this bigger range. What range you want for this default subnet? 10.0. For example, I use 1.0/24. Let's say this is the subnet I want for my first subnet. So this on this subnet level, this is what I was telling you. The DHCP is activated automatically. DHCP protocol, which is dynamic host configuration protocol. What does it do? It assigns IP address dynamically or automatically. Okay, so this is automatically activated. So you know that you have seen that Azure is reserving 5 IP addresses from each subnet. So we're creating this subnet, right? 10.0.1.0/24. This is my subnet. So out of this subnet, now what is my valid IP range? 10.0.1.0 till 10.0.1.255. This is the complete IP range I get from this subnet. And this subnet, obviously the first IP address I can't use, 10.0.1.0. This is called as a network address. I can't assign that to any machine. 10.0.1.1 is reserved, and it will function as a default gateway. What does it mean? For example, let's say I have 2 subnets. I have one more subnet called dev. You can rename this default subnet to production or whatever you like. This is my dev subnet, and this subnet is 10.0.2.0/24, and I have the virtual machines in it. And this is having the IP address 10.0.2.1, sorry, 2.10. I can't assign one. This is my IP address, and I have a virtual machine here, which is assigned the IP address 10.0.1.10. Okay. So these are 2 virtual machines. Now, when these 2 virtual machines need to communicate to each other, let's say I want to access some file share here, or vice versa. So how this connection will go? It will go through the default gateway. So your subnet in the background, it has a default gateway configured, and that has an IP address assigned 10.0.1.1. That's reserved for the default gateway. So this virtual machine will know that, okay, I'm trying to access a network which is not in my subnet. Okay, with the help of this IP which is assigned to this. So the VM understands that this is not a same machine on my network. So the machine has the intelligence to forward that request to default gateway. So when the request comes here to the default gateway, within virtual network, your default gateway knows all the subnets which are under the same virtual network. So it knows, okay, you're trying to access 10.0.2.0 subnet, and that's here. And this is all happening in the background. You don't have to really worry about how this is happening, how this is working. Now, what I'm trying to explain is that every default subnet has these characteristics basically, and these IP addresses which are assigned and reserved. So network address cannot be assigned to anything. Default gateway address is also reserved, and there were few more IP addresses, right? 10.0.1.2 and 3 are reserved for DNS purpose, name resolution. We'll see when we use that. There were totally 5 IP addresses which were reserved. Does anyone remember? Let me go back to my slides. Okay, so .0 is a network address, .1 reserved for the default gateway, 2 and 3 reserved for DNS,
No,
and
slides are not visible.
not visible. I'm not showing it. I'm just going through it to explain you on the whiteboard. Actually, there are, yeah, so there's last address which is reserved for broadcast. So these IPs are not assigned broadcast address to any you can't assign these IPs to any virtual machines within your network. So every subnet is automatically reserving these IP addresses. That's what I'm trying to explain here. So how many IPs you can assign, which IPs you can use? You can use the usable IP addresses. What you'll have is 10.0.1. From 4 till 10.0.1.254. These are the usable IP addresses. And your subnet is again having this range automatically available with it in the pool. It's called a pool of IP addresses, right? This is all happening in the background. You can't really see where is that pool, how I can manage that pool of IP addresses. You don't really need to bother about that. So every subnet will have a subnet address assigned that will have these 5 addresses which are reserved. Okay, that's what you need to understand. Subnet is created, IPs are reserved, and it maintains a pool of available IPs which you can assign to your virtual machines. Now, how you assign this IP address to the virtual machines? The moment you create a VM, let's say this is my first VM. So what will happen? It will pick up the IP from this range. It will automatically have IP address 1.4 assigned from this range. And the moment you create a second virtual machine in the same network, in the same subnet, it will automatically assign an IP address 5 in the sequence until 254 number of virtual machines which you create. Those all virtual machines will be assigned a dynamic IP. It is called a dynamic IP. So that's what dynamic IP means. I hope it is clear. Now, in the scenario where you want, okay, let's say you want to say that I gave you the requirement wherein you need a particular virtual machine to be having a static IP. So you don't want this machine when you're building this virtual machine. You want to say that, okay, I want to fix an IP address for this. I want this virtual machine to function on this IP address. So you have to assign a static IP address. So it will be again from this pool. There are different ways of doing it. You can reserve this IP address. There's a concept of IP reservation. We'll see that how we can do that. You can reserve this IP address from the pool so that your DHCP function, which is running on the subnet, it does not assign this IP to any other virtual machine. So these are the this intelligence, all of this what I've explained is all built into your virtual network. You don't really have to do anything. You just need to understand how it is functioning and what is happening with the IP addresses. I hope I made it clear. If you have any doubts, please, this is the time to ask before we continue, because it gets complicated going forward. You need to understand these things very clearly. Anything, don't feel that you're asking a silly question or so. No question is small. I would just, I definitely appreciate anyone coming forward with the questions. Okay, so if you're okay, if you're good, we'll continue with the slides. So all these concepts which I've explained right now on the whiteboard, and those are all topics which are covered in the exam. So this is where we are. So I have explained you the IP addresses which are reserved by every subnet. And this one, it says that best practice, you may decide to separate dynamically and statically assigned IP resources. So what you have to do is you have to create two different subnets. In one of the subnet wherein you want all your servers to have static IPs, don't you assign it manually. When you create the virtual machine, you can assign the instead of your DHCP function, which is working on in the background, it will assign the IP automatically, but you can change that. You can change and make it a static IP so that it remains the same every time you start your virtual machine. Okay, so we have seen what is private IP and the public IP. Okay, I was saying where you can assign the public IP. Now, whatever we have seen so far, there was there was only one need of assigning the public IP, which is for the web server. So if I go back to the whiteboard again, I feel it's very important for you to understand the concepts rather than running through these slides. So going back here in the same example, let's say where we need the public IP. I have the virtual network. So far, whatever we have done, there was no need of assigning a public IP in this example, because we are having the virtual machines. We are having a virtual network created. We have two subnets. We are deploying the virtual machines to each subnet, and these virtual machines can talk to each other without any problem, without needing a public IP address. What if this virtual machines need access to the internet? Now, internet access doesn't work without having a public IP address. Okay, VNet again. This is a VNet. So I have my subnet. And I have my virtual machine here. Let's say this is again 10.0.1.0/16 10.0. So this is 00/16 1.0/24 I'm using, and I have my virtual machine assigning IP address 10.0.1.2. Is this a valid address for my explanation? A quick check with you guys. Is that a valid address which I am assigning to my virtual machine? Anyone? I hope there are people who can speak there, right?
Yeah, Maksud bhai. 10.0.1.0, 1.1, 1.2, 1.3 you cannot assign. 1.4 should be valid.
Exactly. So this is not a valid address. You can't have this IP address assigned to your virtual machine. And the reason is I have explained you, there are 5 IP addresses which are reserved. So this falls under the reserved IP address. So you can't really assign this IP to your virtual machine. So you can start assigning it from 1.4 up until 254. Now this is automatically assigned. If you want static IP, you can change fix a specific IP for this particular virtual machine. Okay, so now when do we need the public IP? This is my virtual network, this is my subnet, this is my virtual machine. Now you need the public IP for multiple scenarios. For example, this virtual machine, which I have built, I want to make it as a web server. And you know what is the function of the role of the web server? Is to host the website. And I won't host the website just for myself. I will be doing it for the users on the internet, right? So this is the internet user who needs to access your website. Okay, so how do I do that? What do I need in order to have this? We have seen on-prem scenario, you would have to buy an internet connection from your ISP with and also the static IP address from your ISP, the static public IP address, in order to make your website experience seamless and to make it available all the time for all internet users. Right? Now, this is in Azure. We can't buy the internet line here because the internet connectivity is provided automatically by Azure, and they charge for it. Yes, when you need a public IP, you can buy that. We have seen there's a SKU available, wherein you can choose what kind of public IP you need for your requirement. For this requirement, we need a public IP address, static public IP address. Okay, so you buy a static public IP address from Azure. Let's say you get an IP address of 5.2.3.4. This is just an example I'm giving you. And this IP is unique, is assigned to me. Now this IP address I have assigned, and I have connection to the internet. This is the internet. Okay, and this user access this website? Yes or no? What else is missing here? Do I need something else? I purchased a public IP address from Azure. I got this public IP, static IP, which I will be using for my website. So what is missing here now? Can a user, my question is, can a user access my website with the name www.abc.com?
No,
No. Why? Why no?
A record is not there.
Sorry?
A record.
A record is
DNS
not
A
there.
record.
That means there's no DNS entry.
Yes.
Your machine will not know what does it mean by abc.com. Okay, your machine, every machine on the internet, it acts as something called DNS client. That means it knows to reach to DNS server for name resolution. It reaches to the DNS server wherever your DNS server is on the internet. So I'll have a DNS server on the internet. So that internet DNS server will have the mapping of my domain name to the IP address. So I've just bought the IP address. I've not bought the domain name. So I need to also buy a domain name that you can do either again from Azure itself or from a third-party DNS provider. For example, GoDaddy is one of the famous platform where you can buy the domain names. For let's go and see. Okay. What you can do, we can go here. This is a service provider who sells the domain names. So what domain you're looking for? For example, I am looking for abc.com. Does it really exist? They will first definitely check if this is used by someone else. You will not be able to buy that domain name. So this is already taken by someone. So that means there is literally a website with the name abc.com. So let's check what that website looks like. Since we're using it on every session, abc.com. It is possible that someone has bought the domain but not built any website on it. Yes, there is no website exists, but this domain is bought by someone. It's reserved, so I can't use that. So these are the service providers from where you can buy the domain names. So similarly, you can buy the domain name from Azure as well, Azure also. So I just don't buy the static IP. I'll also buy the domain name. So abc.com, when I buy the domain name and your domain name and the DNS, you can configure, okay, for abc.com, my public IP address is 5.2.3.4. Now, when this user on the internet try to access the abc.com, every machine on the internet which is connected to internet, which is capable of connecting to internet, will have the DNS client. It will be functioning as a DNS client. That means your machine knows how to resolve those domain names. So it knows that, okay, I don't know what is the meaning of this abc.com, but I know there's something called DNS server which can resolve this name to the IP address and give me the IP address. So it will over the internet, it goes to the DNS server, and DNS server returns the IP address for the abc.com 5.2.3.4, and your machine over the internet, it reaches this particular public IP, because we know that every public IP is unique, and these IP addresses are managed by the internet, the organization INA, who allocates the public IP addresses for each region, each cloud service provider. They decide who owns what IP address. So through that, they know that, okay, over the internet, this IP is assigned here. It will come here over here, reach your virtual network. Now again, on the virtual network, this IP, public IP, you can directly assign it to the virtual machine. So in this scenario, you will have a private IP assigned to your virtual machine as well as a public IP address assigned. You can directly assign this IP to the web server. So this is how your web server will be accessible over internet. Understand my point? So this is one of the scenario where you will need the public IP address. You can assign it to the virtual machine directly. There are other scenarios which we'll be discussing later, because we have not discussed about
But we
load
can
balance.
still able to access the website without a DNS record, with only just providing the IP.
Yes, that makes it much more clear for understanding. You can, if you know the IP address, if you're a user who knows that this IP address is the IP address of the web server, you can directly put that IP address in your browser, right? Instead of domain name, you put the IP address and it will directly reach your server. It doesn't go to DNS or resolve the domain name and then find which IP address it owns, it's mapped to, and then it reaches the web server. So with IP, you can directly reach the web server, of course. But is it practical? It's not practical. Not everyone would like to do that. Find out what is the IP address. So how do you find the IP address of the web server? For example, I have a web server. So there is something called DNS lookup, DNS lookup tool. Okay. So I want to know the IP address of google.com, for example. Okay, it tells you that, okay, google.com has this IP address assigned. So if I know this IP address, can I
And
browse
also
the
do a DNS lookup from the local machine itself using NS lookup.
exactly. See, what I've done, I've just put the IP address and it came to google.com. So in background, actually it works on the numbers in the for the machines. The names are mainly for us. The DNS is mainly for us to understand our access the resources over the internet over the name with the names. And DNS lookup you can also do as Mr. Hari is saying. We can go to the command prompt as well on our machines. Where is this here? Command line prompt. Okay. So there is a tool called NSLOOKUP, which also does this similar thing what NSLOOKUP on the internet is doing. Okay, so from here also you get, okay, for the google.com, this is IP, so I can access this site with the IP address. I don't have a DNS server configured, right? So this will also show you, I'll also show you that how the IP address is assigned. See, this is the IP address assigned to my machine by my internet router, which is available at home. There's a wireless connection. So this is the IP which is assigned to my machine from the range. This is subnet mask, and this is the default gateway. That means that's the router IP address which I have, through which I'm able to connect to the internet.
Or you can use a local host file with a name and the corresponding IP to browse with an
Yes,
IP.
exactly. You can do that as well. You can use a host file to resolve the host names. Okay, so let's go back to our slides. I hope you guys are following, and it's making things clear to you where you would require public IP on the Azure, particularly where you have to buy the static public IP. We'll see the other scenarios which are discussed here in this slide: load balancer, VPN gateway, and the application gateway in the later sessions. Right. So allocate or assign private IP address. You can again assign the private IP to the virtual machine, to the load balancer or application gateway. And the IPs can be assigned dynamically or statically. Okay, so here we come to network security groups. So before doing this, let's go through the virtual network lab, creating a virtual network, creating a subnet, and checking the IP address assignment. Yes, Khaja.
Masud bhai, actually, I just want to know, like, just now you tried to access the Google website with the IP, correct?
Right.
Okay. I tried with other, like my company with the IP, but it's not
Some
reachable. Why there?
Yeah, some web servers do not allow that. It's a
Okay.
configuration on the web server, so
Okay.
they don't
Okay.
allow IP address to be IP
Resolved.
address
Okay.
used as accessing the web server.
Okay. I got it. Okay. Thank you.
Okay,
Thank you. Thank
right.
you.
So before discussing network security groups, let's practice do some labs on virtual networks. So let me see what labs we have. So I think I've shared the lab link before, right? If it is handy, can you just put that in the chat? Um, Okay, I think I got it. Okay, so we did the identity entirety lab. We did the subscription and RBAC governance in Azure policy, Azure resources by using Azure resource template. I think we didn't do this lab, right? Deploying the Azure resources with the ARM template, which is part of infrastructure that as a code lab. Implementing virtual machine networking. Let's go through this one. It's a 15 minutes lab. So what are we doing here? We're creating virtual network. Okay. Okay, so let's run through the lab. I'm sure you guys are not able to do the labs after the session, so this is also a very important part which we have to cover. Yes,
Masood bhai, can you just copy paste this link? Like every time when we are doing a lab, because it's very difficult to go and search in the
no
link,
problem. So where should I put it in the
in the
Teams chat?
chat, it's chat. Yes, yes.
Okay, I'll do
So
that now.
for easy for us, directly it will go to this
No
topic
problem.
only.
That's okay.
Thank you.
So you want the link for this particular lab?
Yes, yes.
Okay. Where's my Teams chat? Okay.
Thank
That's if you want to follow along with me, if you have access, you have Azure account created, it's better if you do it. What we are doing here, exactly the same. We can follow that. Let me log into my portal Azure account. Right. So what is the exercise? What is the lab? We need to understand now what we are doing, not just blindly follow the steps from 1 to 10. So it's understanding is very important. This lab is the first of 3 labs. So there are 3 labs in virtual networking that focuses on virtual networking. In this lab, you learn the basics of virtual networking and subnetting. You learn how to protect your network with network security groups. Okay, we are discussing that. We'll be discussing the network security groups after doing the virtual network and application security groups. There's a concept of application security group as well. You also learn about DNS zones and records. Okay, so it is actually this lab is covering a lot of topics here. We have just discussed about network. We have not discussed about network security groups, application security groups, which is coming in the next session, this second half of this session. So this lab requires Azure subscription. I guess everyone has it. Okay. Now the scenario. Your global organization plans to implement virtual networks. The immediate goal is to accommodate all the existing resources. However, the organization is in a in the growth phase and wants to ensure there is additional capacity for the growth. So these are the design factors. These are the factors which based on which you design your resources, your virtual network on Azure. Right? Whatever you have right now, look into that. If you're expanding your network, if you're extending your on-prem network to the cloud, so you need to understand the process. You need to understand the requirement. How many virtual machines you're going to run? What different environments will be running on Azure Virtual Network? So all those, and then capacity as well. The growth, the capacity for the growth. So if your organization is doing really well and there is what do you say, the growth plan defined by the company that and within the next 2 years we'll be growing so much and we might require this number of virtual machine resources, compute resources, network, and so on. So all this comes down to the business again. So you have to consider all of that when you're planning your virtual network too. The core service VNet virtual network has the largest number of resources. A large amount of growth is anticipated, so a large address space is necessary for this virtual network. As I told you, there is no harm going with the large IP address range because this is ultimately this is a private IP address range and it is free of cost. Microsoft or no one else can charge you for any private IP range or addresses which you use on your network. So this is a virtual network. It's totally local to you, and you can use any IP range. So start with the big. There's no harm going with the big IP range rather than going with the small and then struggling later with the IP addresses for your requirement. The manufacturing VNet virtual networks contain systems for the operations of the manufacturing facilities. The organization is anticipating a large number of internal connected devices for their systems to retrieve data from. Okay, the lab, interactive lab simulation. There are several interactive lab simulations that you might find useful for this topic. The simulation lets you click through similar scenarios at your own pace. So there are simulations available. That means it will tell you exactly click this, and do this to complete a specific lab. Create network, secure network traffic. Create a simple virtual network. So it will be helpful for you if you want to run through it. You can do that later. So architecture diagram. This is our architecture. This is the resource group name. Under this resource group, we are performing multiple tasks. Task 1, task 2, virtual network. We are creating virtual network, two virtual networks basically. So this symbol, what you see when it comes to Azure virtual networks, this represents a virtual network, Azure platform. In infrastructure as a service model, this dotted three dots with the brackets, it represents a virtual network. So these are two virtual networks we are creating. Under each virtual network, we are creating different subnets: shared service subnet, database subnet, core services. This is the VNet virtual network itself, which is called core services VNet, in which we are running created two different subnets. This is a manufacturing VNet, and it's running some different. There are two different subnets for different servers. This is what we'll be doing. So these virtual networks and subnets are structured in a way that accommodates existing resources yet allows for the projected growth. Let's create these virtual networks and subnets to lay the foundation for our networking infrastructure. Right, there's a note here. It's a good practice to avoid overlapping IP address ranges to reduce issues, simplifying troubleshooting. Right, overlapping is a concern across the entire network, whether in the cloud or on premises. Many organizations design an enterprise-wide IP addressing scheme to avoid overlapping and plan for the future growth. So this is the best practice. This is a purely when it comes to the role, it's a network engineer role, or the architect role who have to look into this. What IP address ranges to be used, whether it conflicts with our on-prem setups or not. So all this has to be considered before creating the virtual network on Azure platform. So what are the tasks? Create virtual network with subnets using the portal. Create virtual network and subnets using a template. So it is explaining you the way to create the virtual network using portal itself through the GUI, and you can also do that with the template. Create and configure communication between an application security groups. Excuse me, there's a prayer to call here happening. I'll pause for 2 minutes. All right, we can continue for next 10 minutes. Then we'll take a break, half an hour break. So what I would do is basically, since here in this same lab, we are covering application security gateway and network security groups. Let's quickly have a quick discussion on what is NSG and what is. Let's go through the slides. Then I'll give you the explanation on whiteboard where we can use NSG and network security group and the ASG application security group after our break. So just running through the slides, NSG stands for Network Security Group. It's like a firewall for your virtual networks. Okay, it controls inbound and outbound traffic to Azure resources such as virtual machines, subnets, or network interface cards. NIC is nothing but network interface card based on the defined rules. So you can define the rules on your virtual networks. So if you have a virtual network, multiple subnets, so as we have created a block with two subset of blocks. For each subnet, we have a block created. So now there are resources on each block in each subnet, right? If you want to have a restriction between between these two subnets, by default, within a virtual network, within a VNet, the communication is allowed between different subnets. There's no restriction. So if you have two subnets, one subnet for production servers, one subnet for dev servers, all these servers can communicate with each other without any extra configuration required. So in production, in real-time scenarios in production environment, you would not prefer to do that. You want to control the communication between these subnets. So you can do that with the help of network security group. So you can define the set of rules. It's like the access control list, wherein you can say, okay, this subnet A servers cannot access these servers in subnet B or a specific service in the subnet B. So NSG contains rules that allow or deny network traffic. Each rule has source, destination, port, and protocol condition. These are the four conditions you can define. The source IP address, destination IP address, or even instead of IP, it can be a range of IP addresses. It can have a port or the port range and the protocol you can define. So you can apply an NSG to a subnet or the network interface card. So the NSG can be applied on two levels, the subnet level or the virtual machine level itself. Because the NIC, when you say NIC, network interface card is assigned to a virtual machine. How is your virtual machine able to communicate to the network? With the help of network interface card. You should all be knowing that every device which can connect to the internet or the network is having a network interface card within it itself. Be it a smart device, though it is not visible to you, there's a small chip on your smart device which functions as a network interface card. So Azure checks the rules in priority order, lowest number first. We'll see how this priority works. Default rules exist to allow internal traffic and block all internet inbound by default. So we'll see exactly what it means when just by reading the bullet points, you won't really get it unless we go through the scenario and the explanation. Example, allowing RDP, which is port 3389 from your office IP to a VM virtual machine. So we'll see the examples. It doesn't really make sense of just reading this point. Deny all inbound traffic from the internet except 443. So this you can relate to the scenario where we are hosting a web server on our virtual network, right? So we have got a web server configured. We got a domain name registered. We got a public IP address, static public IP address assigned to us, and that static public IP we are assigning to a virtual machine network interface card. And therein we need to allow that website access for all the internet users. So we have to create one rule on network security group to allow that communication. Someone was asking something. Was there any question? NSG equals Azure's built-in firewall. So that controls who can talk to your virtual machine or subnet. So NSG is similar to the firewall. You can say it functions as a firewall, but it's not a true firewall because firewall has many other features in it. So just understand NSG as a access control list. Okay, you're defining access control list to control the communication between your subnets and the virtual machines, right? So network security group, as I told you, you can assign it on the subnet level. This is my subnet, so I can associate the group, the NSG with that, or I can even assign it on the network interface card, which is basically a part of your virtual machine. To simplify management of security rules, it is recommended that you associate a network security group to individual subnets rather than individual network interface cards. Because the more granular you go, if you start assigning the network security groups to each virtual machine separately, it becomes really difficult for you to manage those security rules. So as a best practice, on the subnet level, you define what communication is allowed or denied. So that's one of the best practice we have. I think we can stop here. We'll stop here we'll take a half an hour break and we'll be back. We can say 12:45. We'll be back here. Okay. Until then, goodbye and see you again.